Hi, welcome to my second video in my series on graduate school tips and tricks. In this video, I'm continuing from my first video, focusing on using MATLAB to generate figures that you're preparing for publication in a peer-reviewed journal. So let's go ahead and continue where we left off in the last video. So in the last video, we did an example where we used a line plot. And in this video, I want to sort of extend that to a figure with multiple panels and with different types of data. So let's just fold this figure 1 code for now and focus on figure 2. So in this figure, which I'll call F2, I'm going to create two subplots. So I'll create S1 equals subplot 1, 2, 1, and S2 equals subplot 1, 2, 2. So to learn a little bit more about how subplots work, I recommend that you use the help subplot feature in the command window, but I'll leave that up to you. So S1 and S2 are the handles for those subplots, and F2 is the object for the figure. So I'm going to go ahead and press Control Enter, and we get our figure with our two subplots. So I'm going to borrow some code from the first section just so that to save some time. So let's save. Let's keep the same formatting with a white background, and maybe we'll make a slightly wider plot this time because we have two subplots. Oops. Here we want to use F2. Okay, great. So we have our two subplots here. And how about for the first one, we just do the same plot as last time. Right? Oh, and I forgot my CMAP variable here. Okay. So we have our first plot here. In the second plot, I'm going to be using this data 1, okay, which corresponds to this variable here, which is also called data 1. And you'll notice this data is actually, oh, if I can open this. Why can't I get that? Okay, here we go. It won't let me. Okay, there we go. So you'll notice that this is a 199 by 799 sized matrix. So this is a two-dimensional data set. So what I'm going to do is create a plot of this two-dimensional data. And to do that, I'm going to use image SC of data 1. Quick point, image SC is far superior to p-color. So if you are using the p-color like this function, you should change to using image SC. The reason is that when image SC plots a matrix, it will plot the matrix in the exact same way that you would read a matrix. So if I open up this data file and I look at this matrix, right, it starts in the upper left and ends in the lower right. When you make that plot using image SC, it does the exact same. It preserves from upper left to lower right. So it's a great way of visualizing matrices. P-color does not necessarily do that. So I recommend using image SC. Okay? And so because this is some physical, in this case it's called a vorticity field, because my area of study is fluid mechanics. But the point is that we want these axes to be proportional to each other. So we'll type in axis equal. All right, so let's plot this. And there's some sort of visualization error here which makes it look like it's moving, but it's not moving. This is actually a stationary plot. So because of the aspect ratio of this plot, I'm actually going to change my subplots. I'm going to make this 2, 1, 1, and 2, 1, 2. So yeah, that'll work a little bit better. I also want to get rid of the blank space on the sides. So to do that, I can set my x limit to 0, and then I have a variable called nx, which is part of that data. And same with the y limit, 0 to ny, just for safe measure here. Okay. This is, right now it's using a standard color map. I have a custom color map called red-blue, which looks a little bit better. I'm pressing Control-Enter. Okay, so now we don't have really any reference to the magnitude of this data, so I'm going to use the color bar command. And we can see, okay, we're at about plus or minus 10. So I can type C1 equals color bar, which creates a handle for my color bar so that I can customize its position and location later on. And I'm also going to change the limits by using the clim function to -5 to 5, give us a little bit more contrast. Okay, great. In this case, like for this data, the tick labels don't actually correspond to anything important. So I can use the set function to hide those. So I can set GCA x tick label to an empty vector, y tick label empty vector. And I'll get rid of those labels. Looks a little bit nicer. Now say I wanted to change the position of the color bar, right? So one way of doing that is to physically drag the color bar around. You put it in the position that you want. You can then open up the property inspector by right-clicking on the color bar and clicking on property inspector. And this is a really good way of sort of grabbing properties of your figure that you want to change in the code using the set command. So I can go to position, and I can find the position, and then I can simply copy its new position. And in the code, I can use the set command to refer to the C1, say I want to set its position, and then paste the new position. And so that's one way of making adjustments to the figure and then pulling out those adjustments through the property inspector so that you can set it in the code itself. Very, very useful. Another thing you can do, like suppose you wanted to refer the reader to a specific part of your plot. You can go to insert and you can insert any of these objects. It can be, a text box, rectangle, ellipse, a new set of axes. In this case, I'll say insert an arrow, and I'll just drag and drop an arrow like this, right? And so I could, I could also add an arrow in the command code, or in the command line. I'm sorry, in the script. But a nice way of sort of generating that code for you is you can just right-click and click on Show Code. And then MATLAB will generate it. You can then copy and paste. So this is using the annotation function. I don't need to save that. You can then paste it into your code. But since it's going to create just a generic object here, you're going to need to make sure you refer to your specific figure. In this case, it's going to be S2 for this subplot. So I can press Control-Enter. Oops. Oh, sorry, I think here I need to actually use GCF. There we go. And it's added the arrow. So that's a really useful thing to know. Okay, so what else do we want to do? Oh yeah, another thing you can do is you can actually label your color bar using the ylabel function. So, for example, I can add ylabel and then refer to C1. And then I'll type in, this is vorticity / omega _ 3. And the interpreter is latex. And then that will create a ylabel for my color bar. It's very, very small, so we want to make that font size bigger. There we go. Okay, the last thing that I'm going to cover in this video is, well, actually, I got two more things. One is adding subplot letters, so like A and B, and then we'll talk about saving. So you can use the text command to add plots, or to add text to your plot, or you can do what I showed earlier, where you insert a text box. Where did it go? Text box. And then I can say, okay, this is going to be A. I can open my property inspector, say I want it to be times, font size of 16. And then once I've set everything the way I want it, I can show the code and simply copy and paste into my main code. Oops. No. And if I press Control Enter, I've got my A here. It's also looks like it's got an outline that I don't like, so we can get rid of that. There we go. Oh wait, nope, that's the wrong property. Text box, here we go. Use none. There we go. And then I'll regenerate that code. And don't forget to set the object to GCF. And you could do a similar thing for the second panel and label it panel B, but I'll leave that up to you. Okay, so the last thing I want to show you is saving your figures. There are two commands that I recommend you use. One is save fig. As you might imagine, that's pretty self-explanatory. The first argument is the handle for your figure, in this case F2, and then what you want to call it. So I'll call it figure2.fig. Now this is useful just in case you want to open and inspect your figure in MATLAB. But the other thing you can do is use the save as function. And in this case, you can use a file format that the journal's going to like. So what I recommend using is the .eps file format and specifying a colored eps file format as part of the arguments of this save as function. This is a vector graphics format, which means that the journal will be free to resize and reposition your figure, and it's not going to lose any resolution. It's just going to look great. So use that .eps when you can. And so if I press Control Enter, now that should save, and I've generated my two figure files. In general, it's sort of best practice to store this in a new folder, which I'll call figures, and drag those into that folder. So you might add, figures on your in your save commands. Okay, so that's all for this video. I hope the content that I covered was helpful to you. And again, please feel free to add your own tips, your own advice to your fellow graduate students in the comments section. Thank you.